You're welcome to my class today. Now, last class, we started equilibrium and we were able to solve some examples. But today, we are looking at triangle of forces and Lami's theorem under equilibrium. At the end of this lesson today, students will be able to solve problems on equilibrium using triangle of forces and Lami's theorem. That's establishing our learning objective. Now let's kickstart our business for the day. Let's begin by looking at what we call triangle of forces. Now let's consider three coplanar forces as we can see on the screen right now. Three coplanar forces, we have F1, F2, F3. Good. Now we can put each of these forces on the sides of a triangle. That's why we call it triangle of forces. Each of the forces can be represented on the sides of a triangle. Now, let me begin by drawing my F2. This is my F2. As you can see, that's the direction. Look at the direction of the F2. That's this F2 here, the F2. Then my F1 that way. Look at it, this is still the same direction. F1 like this. It's just that I've connected it to F1, so representing the second side of the triangle. You see my F3 here, this F3 here is a downward force, so I connect it down this way, so that becomes my F3. That's F3. So I've connected each of the forces to form a triangle. So each of the forces represent the sides of a triangle, and I'm only trying to show you how I obtain this diagram by drawing it for you live. Okay, that's how we obtain that diagram, and we just name the triangle ABC. Good. Let's forge ahead. Let's just see what the triangle of forces is saying in form of statements. The triangle ABC represents the three coplanar forces. Hence, if three coplanar forces act on a body in such a way that the system is in equilibrium, then the forces can be represented in magnitude and direction by the sides of a triangle taken in order. And that is what the law is trying to say here. We can represent each side of the triangle with each of the forces. So the triangle drawn representing the three coplanar forces is called triangle of forces. So the name triangle of forces is obtained from what? A triangle, because each force represents a side of the triangle. Let's move ahead. Let's see what Lami's theorem is saying, because these are the two things we are going to be applying today. The triangle of forces and Lami's theorem. What does Lami's theorem has to tell us? Lami's theorem states that if three coplanar forces acting at a point are in equilibrium, then each forces is proportional to the sine of the angle between the lines of action of other two forces. Okay, that's just stating it, Lami's theorem in words. Now let's look at this diagram to explain what Lami's theorem is saying. The forces F1, F2, and F3 represented that way. So how do we apply what we call Lami's theorem? This is the real Lami's theorem here. This is the Lami's theorem, okay? Now, when you have a force that way, my F1 over, that's the angle. What's the angle between the two other forces? I'm talking F1 now. The angle between the two other forces is beta. So that's why I have sine beta here. F1 over sine beta equals to, now the other force F2. if I'm looking at F2, what is the angle between the two other forces apart from F2? That's this gamma. So that's why we have F2 over sine gamma there, okay, equals to F3. If I want to use my F3 now, what's the angle between the two other forces? That's theta. That's why we have F3 over sine theta. So this is the real Lami's theorem. What does it look like? Can anybody guess? Yes, it looks like sine rule, just like sine rule that we have applied while we were solving bearing. Good. So let's forge ahead. So that's how simple Lami's theorem is. Let's forge ahead and let's quickly look at this first example, example 1. And let's see how we apply the triangle of forces and Lami's theorem. Remember what those two things are talking about is what? Three coplanar forces in equilibrium. When forces are in equilibrium, three forces are in equilibrium, three forces precisely now. We can use triangle of forces to solve, or we make use of Lami's theorem. Now let's look at the example. A body of mass 6.5 kg is supported by two strings. This is the mass 6.5 kg. The G you are seeing there is acceleration due to gravity. That's the mass. No, W is mg. So we have 6.5 times acceleration due to gravity representing our weight. Okay. A body of mass 6.5 kg is supported by two strings. Where are those two strings? The two strings are represented on my T1 and T2. Good. One of the string is inclined at an angle of 30 degrees and the other 40 degrees to the horizontal. And that's why you see this 40 and 30 degrees there. Okay, that's the angle of inclination to the horizontal. So you see a broken line just below those angles here. There's a broken line there just along that path. The broken line here, that's the extension of it. So we have 30 degrees and 40 degrees showing us the inclination of those the tension on the string. Good. Find the tension in each string if the system is in equilibrium. So when you see a question like this, what should come to your head is Lami's theorem or triangle of forces. Three forces. We have the weight. Weight is the number one force. This weight, the weight acting down here, acting downwards is the number one force. Then the other T1 and T2. Those are the two other forces, making three forces. So these three forces are said to be in equilibrium. When three forces are in equilibrium, what should quickly come to your head to solve this type of question is Lami's theorem or triangle of forces. Now let's see how we applied triangle of forces to solve this question. Good. Let's turn those forces to form a triangle now. Okay, my T1, look at my T1. The direction of my T1 on that diagram is like this. So this becomes this T1. I'm trying to show you how I obtain this T1. My T2, look at the direction of that T2 on that diagram. It will still follow the same orientation, the same order. Look at that arrow, the same direction of that force. Then my W is acting downward, so I will connect T1 and T2. So don't forget, this is my T2 and this is my W. How is it? What's the direction of it? It's going downward. So that's how I got this diagram we are seeing here. Okay, remember we are told that the forces are acting how? They have directions to the horizontal. T2 is what? 40 degrees. So that's how we have 40 here. And that's how we have the 30 here. That's the same thing I'm having here. I'm just showing you how I obtained that triangle. Good. How did we arrive at the angle 60? This 60 you are seeing and this 50 you are seeing here. Okay. Now if I make an extension here, alternate angle, this angle here is 30 degrees. Why? Alternate angles. Okay, here we also be 40 degrees. That angle there we also here we also be, we are just put dots now, we also be 40 degrees. So the angle, if here is 30 degrees, this angle here will be what? 60. And the angle I have here will be what? 50 degrees. Because that's 90 degrees. Here is supposed to be 90 degrees. So that 90 minus 40 gives us 50. 90 minus this 30 degrees gives us this 60 degrees. Now that's how we obtain that triangle and all the information on that particular triangle. Now let's see how we're going to use that to solve this now. Look at it. We label our triangle OAB as shown. What we are simply going to apply here is your what? Your sine rule. That's your what? Sine rule. That's the sine rule we are applying. Okay. Remember your T1, where your T1 is, the angle facing T1 is 50 degrees. That's why I have this T1 on that triangle. T1 over sine 50, then 6.5 G, which is the weight, over 70 degrees. Remember, we have something like this there, 30, and we have 40. So that's why we have 70 degrees, sine 70 degrees. That angle here, this weight here is 6.5. That's why we have what we have there. So what I'm applying here to solve a triangle, of course, we know we don't apply a sine rule until we have a triangle. So since we have a triangle of forces, we can apply sine rule to obtain those forces represented on the side of the triangle. So if I make T1 my surrogate of the formula, cross multiply appropriately, you have this information there. So if I multiply my G, remember my G was given to be 10 meter per second square. 10 meter, okay, that's 10 meters per second square. Okay, look at it. If we multiply 10 times 6.5, I have 65. That's why I have this 65. The 6.5 G has turned to 65 because we have multiplied it by 10. Then the value of sine 50 is this divided by sine 70. So simplify, we have our answer. Very simple. So we have applied triangle of forces, then using our sine rule. It is your sine rule that will eventually give you the forces you are looking for. Now let's see how that's our T1. That's obtaining using triangle of forces to solve that particular question. Now let's see how we can apply Lami's theorem solving the same question. Lami's theorem solving the same question. T1 over sine 130 degrees equals to W over. Now, if you look at that diagram, the diagram for that question, remember I have something like this. I have something like this. I have, let me sketch it properly. I have something like this. I have something like this. Okay. That is 30 degrees here. That is 40 degrees here. And this is my W. The angle. How do we obtain all those other angles? Remember, here will be 90 degrees. Here will be 90 degrees. So the whole of this angle is what? 90 plus 40, 130. The whole of this angle will be what? That's 90 plus 30, 120 degrees. Then the remaining, if you add this and this 120 and you remove it from 360 degrees, you are going to have the balance of 110 degrees. Remember, angle at a point is what? 360 degrees. So add 130 plus 120 and divide by and subtract from 360 degrees. Good. So applying our Lami's theorem, this is my T2 and this is my T1. T1. Okay, so T1 over sine 130. T1, the angle facing T1 between the other two angles is 130. So I have this equals to W. What's the angle between the other two angles? That's 110 degrees. So cross multiply, you have this, and when you simplify further and punch your calculator, our answer gives us 52.98. Okay, now that's obtaining T1. We want to obtain our T2. Obtaining our T2, we do the same thing. T2, that's over, what's the angle between the two other forces? 120 degrees. That's why we have this. Then W over 110, the angle between the other two forces. That's why we have what I have here. So cross multiply, you simply have this. Simplify further, punching your calculator, you have this. The process is very simple. I believe it is clear to everybody. Good. Now let's see our example 2 very quickly. A body of weight 12 newtons is supported by an inextensible string of negligible weight, inclined at an angle of 60 degrees to the downward vertical and a horizontal force F newtons. Assuming the system is in equilibrium, calculate the magnitude of F, the tension in the string. That's the sketch. A body, the weight is 12 newtons. That's why you see that force coming down. That's why you see this force coming down, 12 newtons. Okay, you have another one this way, which is the F. Then you have the tension this way, which is the tension of that particular string. Okay, good. Let's see, how did we arrive at 150 there? 90 and 30 degrees. It is inclined at an angle of 30 degrees. Here is 90. That 30 degrees plus 90 gives us 120 here. As you can see, that's the 120 you have there. Okay, now here 90. You can see this 90 here. This 90 at that point. So add the 90 and 120, subtract from 360, you obtain your 150 degrees. So let's quickly apply our Lami's theorem. Okay, now I want to obtain T over what? Sine what? What's the angle between the two other forces? That's 90 degrees. That's what you have here. Okay, over 90 degrees. That's here. Then equals to the force. What's the angle between the other two forces? That's 120 degrees. That's why we have that. Equals to the force W over sine 150. The angle between the two other forces when I consider W is what? 150. So that's why I have this. So if we simplify that, okay, we're going to obtain all the forces required. Now the first one, Roman figure 1, is they ask us to find the magnitude of that force. F, so we can only use two of the equations together. F over sine 120, 2F over sine 150 degrees. Okay, so if I make F my subject of the formula, what do I have? 12 times sine 120 over sine 150, which is also equivalent to this. Okay, you know that sine 30 is equal to half. So that half, if you divide 12, that's how we have 24 here. Sine 60 is 0.8660. So we multiply, I already have my force. That's my force there. Okay, to obtain the tension in the string, I apply the tension T over sine 90 degrees equals to 12 over sine 50. Okay, so equating those two from the Lami's theorem, these same two are from Lami's theorem that we showed in the last slide. These two are also from what? Lami's theorem, because we can only find one unknown. Okay, so with this now, I have T over sine 90 degrees equals to 12 over sine 150. Making T my subject of the formula, I have 12 times sine 90 degrees over sine 150 degrees. Good. My 90 is 1. The value of my sine 90 degrees is 1. Sine 150 degrees, point your calculator, you have 0.5 degrees. So if we simplify further, we have our final answer, which is 24 newtons. So that is how simple our Lami's theorem is, and our triangle of forces. Good. This is how far we'll be able to go today. Let's summarize what we have done today. Quick summary: we talked about triangle of forces, and that is what you can see on the screen there in statement form, that when you have three forces can be represented on what? It can be represented on a triangle. Good. It can be represented on a triangle. That's what the triangle of forces is talking about. Then the Lami's theorem is just like, remember I said it looks like our sine rule. So we've been able to look at triangle of forces today, and been able to look at Lami's theorem, and we have seen how to apply these two forces, these two theorems to solve some questions. Don't forget to post your questions, and I will duly attend to all the questions. Immediately after this, watching this video, make sure you attempt the quiz that is connected to this week. You see the tile there after watching this video. Thank you for listening. Thanks for your rapt attention. See you in the next class. Thank you. Good.